All right. This is also a question in vector and mechanics. We are asked to determine the resultant force. As we all know, resultant force is a single force whose value is equal to sum of all forces acting at a point. So if you look at the diagram carefully, we have forces 150, 100, and 50. They are acting at this point. So to determine the resultant force, this is like the definition is a single force. So the sum of all these forces, when you give us a single force, that value is called resultant force. To do so, we need the concept of resolution of forces, sign convention, and cardinal points. So anytime you want to resolve a force, your interest should be the force and the angle inclined between the force and the horizontal axis. The horizontal axis is the x-axis. For the first force, 150 degrees, you can see it's inclined to the vertical and not to the horizontal. So our interest is the angle inclined to the horizontal. But don't forget, every quadrant, according to cardinal point, is 90 degrees. So the whole of this angle here is 90. So if here is 45, that means here is also 45 degrees. Like I said earlier, our interest is between the force and the angle inclined to the horizontal axis. So if you look at the force of 100 Newton, the angle between the force and the horizontal axis is 30. But you look at the force of 50 Newton, the angle between the force and the horizontal axis is 10. It's 10 between the 100 Newton and 50 Newton. But our interest between the force and the horizontal, which is from here to here. So if you go by that, the angle between the force of 50 Newton and the horizontal should be 40 degrees. So not 10, because the 10 is between 100 and 150. Our interest between the force and the horizontal axis. So if I sum these two angles, I'm going to have 40 degrees. With that, I can now resolve this force. To resolve a force, let's consider a single force system. And the angle between the force and the horizontal axis, let's call it theta. And here's my vertical axis, let's call it y. So if I want to resolve this force, that means I'm taking the force to the vertical, I'm also taking the force to the horizontal. To do so, I will apply SSCE. So opposite and hypotenuse is sine. So here will give me F sine theta. Adjacent to hypotenuse, that is cos, here will give me F cos theta. That is to say, anytime I'm resolving this force to the vertical, if and only if the angle is inclined to the horizontal, is the force and the sine angle. Anytime I'm resolving this force to the horizontal, if and only if the angle is inclined between the force and the horizontal is theta, I'm going to have F cos theta. So with that, this force is now a dummy force, because we now have the vertical axis as F sine theta and the horizontal axis as F cos theta. So if here is F sine theta, here is also F sine theta. So we also need this concept of sign convention. If you have two lines perpendicular to each other, they will meet at a point 0, like other points, our reference points. Here's my x-axis, here's my y-axis. If the arrow is acting towards the right-hand side, it's a positive force. If the arrow is acting from the reference point to the opposite direction, it's positive force. If the arrow is acting to the left-hand side from the reference point, it's a negative force. The arrow is acting from the reference point downward, it's also a negative force. With that, let's resolve this force into vertical and horizontal components. That's the only way we can determine our resultant force. Resultant force is a single force whose value is equal to the sum of all forces acting at a point. It's a single force. So by resolving all these forces into a single force, we have our resultant force. So let's do that. I have my summation F of y. So I'm resolving this force now. The force is 150 and the angle inclined to the horizontal is 45 degrees. So I'm taking it to the vertical force or the vertical direction is the angle and the force of 150. But the trig ratio is sine. Anytime resolving to the vertical direction, and according to sign convention, what we have here is now a positive force. So this will give us 150 sine 45 degrees. So if I want to resolve this force, the force of 100 Newton to the vertical direction, so this is also the opposite side of this vertical line. So we can see the 100 Newton force is coming towards the negative direction of the line. So that will give us minus 100 sine 30 degrees. I'm using 30 because the angle between the 100 and the horizontal axis is 30. Then if I want to resolve the last force of 50 also to the vertical axis, you can see it's acting downward. Going to sign convention is negative. I will have minus 50 sine 40 degrees. So let's use calculator to resolve what we have here. Summation f of y will give us t sine 0.0. 100 sine 30 is 50. 50 sine 40, 2.14. If I subtract 106 minus 50 minus 32.14, I will have 23.86 Newton. So my f of y is positive value. It's positive. So let's also resolve the forces to the horizontal direction. That will give us summation f of x. So if I'm resolving this force towards the x direction, you can see it's acting towards the right hand side. According to sign convention, that is a positive force. So this will give us 150. I'm resolving this man also, the force of 100 to the horizontal axis is also a positive force. That will give us 100. And the last force of 50, if I resolve to the horizontal, you can see it's also acting in the positive x direction. That will give me plus 50 cos 40 degrees. So if I use calculator to simplify what I have, 150 cos 45 give me 106.6. 100 cos 30 is 86.60. 50 cos 40 is 38.30. If I add up, I'm having 106.6 plus 86.6 plus 38.3. That will give us 231.5 Newton. F of x is also positive. Our f of y is positive. So if you go by sign convention, this is positive, positive, negative, negative. So our f of y is positive. That means it's going this way. Our f of x is also positive. It's going this way. With that, I can now draw my net force diagram. The net force diagram now. Net force diagram. Our f of y is positive. Our f of x is also positive. So direction. Positive, positive. Here is now my y. Here is my x. Then, according to parallelogram law of vector, the resultant force should always come from the point of concurrency of the two forces, which is from here. So here I will have my resultant force R. So my f of y is positive, which is 23.86 Newton. My f of x is also positive, 231.5 Newton. This is now the direction of the resultant. So with that, to find the resultant force, I will apply Pythagoras theorem that says the square of the hypotenuse is square of the adjacent. Adjacent is now my f of x, and the square of the opposite f of y. So if I fix in my values, f of x is now 231.5 squared, f of y is 23.86 squared. So I'm having r squared as 231.5 squared. That will give us 53592.25 plus 23.86 squared. That will give us 569.2996. If I add up 231. If I add up, I'm having 54161.5496. So my resultant now is now the square root of that, 54161.5496. That will give us 2373 Newton. So from the diagram given to us now, you can, at the end of the day, we are now having a single force. Like we defined earlier, resultant force is a single force whose values is equal to sum of all forces acting at the point. So the sum of all these forces from this diagram is giving us a value of 232.73. That makes it the resultant force. If you have anywhere that's not clear to you, you can always state it on the comment section. Thank you for watching.